All right, well, this is my Millwright MegaVee CNC router. I've already done some mods to it, and upgrades, but I'm going to talk about some more extensive upgrades that I'm going to do to it. That'll essentially make it equivalent to what they call their MegaVee Pro. So let's take a closer look at it. All right, so the MegaVee is a fairly large envelope CNC router. It's roughly 3 feet by 3 feet by 4 inches as they deliver it. I've actually modified that to get more Z-axis stroke out of it by putting this little extension on here. And MegaVee gets its name from the V-groove and V-groove wheels. It has large Delrin V-groove wheels, which make it better than some of the smaller versions of the same style as far as rigidity and accuracy. And actually, it served me pretty well. It has extruded aluminum beams, and you know, for woodworking and for light duty stuff, it's actually pretty fast. I do a lot of my lost foam pattern making on it, so it's very, very well suited for that. But I need more Z-axis clearance, and I'd also like to improve the motion control and rigidity a bit so I can do some light aluminum machining and just improve the overall accuracy of the machine, which is pretty good right now, but it'll be better. So the motion control is with the V-grooves and the beams. It's a rack and pinion driven by NEMA 23 stepper motors. I'm going to keep the rack and pinion actuation just because it kind of keeps these smaller steppers in the sweet spot of their torque curve on that. But I'm making an entirely new Z-axis and also replacing all the V-groove wheels with 20 millimeter linear rail and linear bearings on that. And while I was at it, I'll add some more clearance under the gantry. I'm going to have 6 inches of active Z-axis stroke that I can use. And you can see this cast dust shoe right here. This was one of my creations, and I have a centrifugal separator and a big shop vac that I run on it. This works really, really well as dust collection. But the one thing that I discovered is having the dust collection hose right out here in front makes it a little bit more cumbersome to get at the collet nut on that. So I'm going to reposition that and remake the dust shoe on the new version too. And a long time ago, I updated the MegaVee to accept this Porter Cable 690. It's a 1.5 or 1.75 router. I don't need the horsepower as much as I wanted to be able to use 1/2-inch shank tooling because I have a very large collection of router tooling on that in 1/2-inch shanks. So the 690 can use either 1/4 inch or 1/2 inch. So that's the way I'm set up right now. Let's go have a look at what some of my upgrade features are on that. And you can see I've just got a particle board, baseboard here for my platen on the table. But let's go take a look at what I've got cooked up. All right, well, these are the various upgrade pieces I've made. Hopefully my plan here is to make a swap over kit, and when I do it, do the swap and get her tuned and ready to go in a day. But I've been diligently making all the pieces, and as you saw in the slides before, I did quite a bit of armchair 2D CAD work to make sure that dimensionally I had everything laid out, and hopefully that'll mean it'll go together without incident on that. The Z-axis you see in the middle there, it sure did. I'm happy with how it came out. We'll take a close look at that, but you can see the table that it's sitting on, as opposed to just the 3/4 particle board bed. It's actually underneath that 1/2-inch ground steel or aluminum plate is 2-inch square structural steel tube weldment with reinforcing ribs underneath it that I welded up, and then I drilled, seemed like a zillion holes, and tapped them there and countersinked them so they're below the surface. So when you put that aluminum tooling plate, that Mix 6 tooling plate, that stuff's pretty nice. It's within 1/1000th or two thickness across the whole dimension of the plate, and that's pretty darn good. And I was able to buy remnants of that, and that was a bit of an investment. I think I got $175 invested into that, which was a pretty darn good price for it. Well worth it. And then I made these end pedestals here. You can see the ones on the MegaVee are just these flat straps, but I put a foot on it and then welded this gusset in, and the beam actually sits on top of here, so everything below the beam is gusseted. And I got those nice and flat, and there's one of those in each corner, and they're anchored into the table very securely. So hopefully that'll make for a very secure foundation for the beams and the gantry system to be mounted to. So let's take a look at the individual pieces of the swap kit, and I'll get a little bit closer here. Stay tuned. All right, well, so this is for sure the meat of the conversion kit here. First off, you can see I've got these 20mm linear rails on all axes. This is the Z. It also holds the bearings for the gantry, which is the X axis. We'll look at the back side of that in a minute. Here's a 20mm linear bearing, two of them on each side. This is the 16mm ball screw on that. It's 10mm pitch on that. I got all the linear slides, a dozen linear bearings, the ball screw, the thrust blocks, everything for about $270, which I thought was pretty darn good. Sure, they're Chinese knockoffs, I'm sure, of the high wind linear motion stuff, but they'll be plenty good for my purposes, for sure. The ball screw kit came with this helical cut coupler. I don't like those because they can wind up a little bit and cause some accuracy problems. So I replaced that with a dual disc coupler on that. You'll see the carriage assembly is actually a casting I made as a lost phone casting, as is the router clamp and the dust shoe. As I mentioned a little earlier, I relocated the hose on the dust shoe so the collet nut was easy to get at. And the router clamp is a separate casting. I did that because it could have all been one casting, but I figure at some point in the future, I could see me wanting to upgrade to a real spindle. And if I did, all I would need to make is a different router clamp for that. So I did it that way. It can be clamped and positioned anywhere along the carriage on that. It's shown at about the mid-travel mark. I've got 6 inches of travel. And when the router is installed in the clamp and it's fully down and the dust shoe is all the way up, the nose of the router and the end of the collet is actually at the bottom of the dust shoe. So I use these stationary dust shoes because almost everything I machine is plank, board, or plate. So there's really no reason for me to have a bristled dust shoe because it just gets in the way and gets compressed, and the stationary ones seem to work better for me. But anyway, it uses the same stepper because I plan on using the same controller as the millwright came with. I've got tons of programs and it's working just fine for me. It does everything I need it to do. One thing I did do is, I don't know if you can see it or not, but I broached slots into the router holder because the Porter Cable 690's got these little guide pins here. In their base, they've got a double lead groove that allows you to twist it and position the height. I didn't need that, but I still wanted to be able to use the router in the hand base if ever, so I just broached slots in there to clear that. But and I've got a bunch of these throat plates here that I've made. They're held in there. There's permanent magnets in the casting here, and I just put washers in the bottom of these medium density fiberboard baffles or throat plates. They're expendable. If you ever munch one, they're cheap to make, easy to make again on the CNC router. I've got all kinds of different throat openings. and the body of the router can actually extend down inside the dust shoe if needed for extra reach on that. So anyway, that's the Z-axis. So I've got ball screw accuracy on that. I probably have, I mean, not probably, I'm sure I've gained some weight compared to, there's going to be more mass to move. Not a lot more mass though, but probably about the weight of the linear rails and bearings are probably about the addition on the Z-axis. Other than that, and maybe a little bit here on the ball screw too, but it's not a huge addition in mass. So I'm still hoping for pretty good performance from the smaller NEMA 23 steppers on that. So let's take a look at the back side of it here for a minute. Let's see if I can turn it around and just have a look. And not a lot to the back side here. You can just see I've got the shelves machine to hold the linear bearings. One here, like so, or one on each side, and then of course one on each side down here. So the gantry has two linear rails, one on top and one on bottom. And I did quite a bit of planning to make sure that I could get all the screws in all the holes as I needed on that. And this is the stepper mount for that X-axis on that for the rack and pinion. So yeah, it's I think it's a pretty stout. It's again made out of that MIC6 tooling plate and lots of screws, and it's pretty true. I did it on my knee mill, and I'm actually looking forward to seeing how it performs. So hold on here and let's take a look at some of the other bits and pieces to make up the kit. All right, well, there's really only a couple other pieces to look at here, and that is these are what go on the end of the gantry beam, and on top they hold the bearings here for the Y-axis. So there's a pair of them and a rail that sits on top of the beam, and then this, of course, is the stepper mount, and underneath the beam, the stepper hangs below here, and it engages the rack on the inside of the beam. So one of these on each side with a pair of bearings and a linear rail. It's a 1/4 inch steel plate and some more of that MIC6 tooling plate for the mounts. And I got a pair of those. I did put a couple sets, each set of 4 are mounting holes, so I can reposition the gantry height if I should ever want to. One thing about having all the clearance and the height under gantry is that what I'll do for machining aluminum and thin stock is I'll just build a platform that sits on this that shortens the height. Otherwise, you'd have to run very, very long bits, and you wouldn't want to do that cutting hard materials. But I need to run long bits, like 4 inches of cutting length sometimes, and 6 inches of stroke when I do my foam patterns. And that's no problem for foam, but I can't imagine cutting aluminum with a 6 inch long 1/4 inch diameter bit, to be sure. So I'll just have a platform, probably about a 15 by 24 or 15 by 30 platform that's 4 inches tall or so, that I've got tooling pins in the plate for, and I'll just mount that on here when I do harder material machining. So that's my plan for it anyway. So I'm trying to get the best of all worlds here. I've got a big machining envelope, but I'm trying to have as much rigidity and lowest mass as possible in the motion control system. So we'll see how it works. We'll take a closer look at it when I get it all assembled and together, and I'm looking forward to that. Stay tuned. All right, well, I've got the conversion completed. You can see the old MegaVee carriage and parts there that I replaced. Let's have a look at the replacement parts. First here, you can see the carriage that is the both X and Z axis there. I put a cap on the beam of 1/2 inch tooling plate. That's what I mount the rails to on that, and also the rack on that. As I mentioned, I retained the rack, and you can see the stepper mounted back there. I did put these two braces on that brace the stepper, just hopefully adding a little extra rigidity to the stationary plate on that. And you can see the limit switch here for the Z-axis, and through the hole there is the limit switch for the X-axis. Here's my dust shoe and the magnetically retained baffles in it. You see I got different throat plates, different baffle plates in there, and there's a little step in the casting, and that keeps it centered, and the magnets keep it in place on that. And yeah, I think everything seems to be moving all right. Something else I did here, if we go around the back side, is I put in these side plates here. I did it for a couple of reasons. One, just for dust, you know, for dust containment, but the other is I think it stiffens it up a little bit because they're screwed into the beams and the base plates, so it does give it some added rigidity as far as the fore and aft here on that. And it gave me something to mount the drag chain support shelf on that. Same thing on the other side. And I had to make these little wings here to secure the top side of the drag chain. Did that on each side, and there you see at the back is the limit switch for the Y-axis on that. And as I mentioned, I just retained the original MegaVee controller. This is a gerbil that I use. So anyway, that's kind of the conversion there. And as I mentioned before, it's all 20 millimeter linear rail and linear bearings. I got it all lubed up. I made some gauging blocks to do my initial setup, but next I've got to do some leveling and tramming and squaring everything up, and then make some test cuts and see where I'm at on that, and just some fine tuning, and it should be ready to go. But I can jog it around here by just on the Z axis. I like the actuation on it, so maybe on back on the Y. So yeah, she's I need to do a little bit of fine tuning, and then I'll have to do some test cuts, and we'll see how she does. Stay tuned. Well, I took it on its maiden voyage here and machined the plenum of this intake manifold, and I'm pretty happy with how it turned out. I was taking it pretty easy. I mean, I was only taking 30 thousandths depth of cut with a 1/4 inch carbide end mill, and I did use cutting fluid because it's a casting. And if you don't use cutting fluid, the cutter can load up, and once the cutter loads up, that can be kind of a disaster. And it makes quite a mess, which I've cleaned up. But I have to say that I'm pretty happy. The surface finish that it achieved is it's quite a bit better than I was expecting. It feels great. You can't, I don't know how much you can tell by looking at it here on the video, but it's a pretty nice finish. This should have no problem sealing an O-ring to it. So yeah, I'm happy with that, and the performance of it seemed to be pretty darn good. I've got the sealing plates that go on the bottom side of this to do. They can be kind of tricky because they use a small end mill to cut the O-ring gland. I'll go ahead and set up and do those, and we can have a look at how they turned out. Stay tuned. All right, well, back with you, and I've got the base plate machine. So I got to drill and tap a few holes, but other than that, the machining's done on the intake and the base plate. But first, a little quick explanation. One, I've got a dust shoe for the router that you saw earlier in the video. I don't use it when I'm machining this aluminum because I put cutting fluid on, as I mentioned, to prevent the bits from loading up. And I just don't want to foul up my whole dust collection system with wet aluminum chips with cutting fluid on it. So, you know, the price I pay for that is it makes one heck of a mess across the table, but it's pretty easy to clean up. And I didn't have room to put the dust shoe on when I was cutting the intake manifold because I don't have enough height under gantry to do that. I could have done it with the base plate, but like I said, I don't want to foul up my dust collection system. The other thing is that I built this sled here. It's actually, I cut up my old platen, my old baseboard, particle board baseboard, and as opposed to taking the time to level the table because I needed to get these parts done, I just shimmed this platform here and ran a dial across it and got it within a couple thousandths everywhere. So that worked out okay. And I can run that way for a little while, but eventually I'll level the entire table so I don't have to monkey around with that stuff, but just that's a project for another day on that. And then the other thing is that the reason I modified this machine, and I went with a I guess what I'll call a conventional Z-axis. The pros and cons of trying to be, you know, an everything machine is that it's the old jack of all trades, master of none story. When I get a lot of height under gantry, you can't get down to the table except with a long bit, and you don't want to machine rigid materials with a long bit. So on the other hand, the majority of what I use my CNC for is machining foam patterns. And I'll spin a 6-inch long, 1/4-inch diameter bit in that router to cut foam patterns in this envelope, but I would never use a bit like that to cut aluminum. So to get a little stiffer, I just raise the work surface up. And if I really wanted it stiffer, I'd turn this the other direction and park it over here next to this beam as opposed to putting it across the gantry. But this is, since I do castings and stuff, I don't remove much stock. I just take light cuts, you know, with maybe a 1/4-inch bit. I really can't swing bigger than that because I'm using a router, and even with the router, I can't get down to proper turning speeds with that, even with speed control. But it's good enough to do, you know, small stuff like this. Here on this aluminum plate, I did the perimeter of it. These are little spot faces here for O-rings, and this around the perimeter here is the O-ring gland, and the mating surfaces are here in the casting, and of course this fits in the casting here, there, and gets screwed on, and that's the O-ring seal for the plenum on the casting. So anyway, that's pretty much going to do it for this video. So that's my conversion to what I'll call, I guess, the my version of the MegaVee Pro, and it's Maiden Voyage there, cutting aluminum. If it's cutting the aluminum okay, which did a lot better job than my old V-wheel version of this machine did. It's just the depth control is so precise on the ball screw. I can actually actuate it 1/1000th of an inch, and it reads 1/1000th of an inch on the dial indicator on that. I could never actuate the old Acme screw one 1/1000th of an inch at a time. But that depth of cut accuracy is kind of important for metal machining on that. But anyway, yeah, that's going to be a wrap for this one. I'm going to go ahead and proceed to build up the carburetor, inline carburetor Boss 9 systems now, and get those off to their customers. And I guess we'll call it a wrap. Until next time, we'll catch you then.